Alright, so this video is going to be reviewing vectors and parametric equations, things that we've covered basically over third quarter that you possibly might see, third and fourth quarter, basically semester 2, that you may see on your semester exam. So the first thing we're going to talk about is vectors, and if you remember, there was kind of two big concepts with vectors. There was what we call magnitude, which is represented by those two lines, and then there's also direction angle. So remember that that is an angle, and the way that you get the reference angle, and again this is reference angle, is using this equation right here. Okay, you will need to determine coordinates in quadrants when we get to that point. Okay. The other big thing about vectors was the dot product between two vectors and then angle between. So those were kind of the big things, and we're going to do some problems now to review those. So the first thing is finding the dot product of the given vector. To find dot product, it's basically you take the x values and you multiply them together, and then you add to that the y values multiplied together. Okay, so that's basically the dot product. You will see that represented right here. So they use u and v. I used x and y. But basically you are taking those values and you are multiplying them, and then you are adding them together. Okay? And you will get what we call a scalar number when that happens. So again, you're getting one single number, and that in this case would be negative 38. Over here, you're just going to multiply 0 times 2 and add to that, 0 times negative 2, and add to that 8 times 7. So that's going to be 0 plus 56, which is just 56. So here's your answer here, here's your answer here. For this one, you're going to multiply 8 times negative 2 and add to that 2 times negative 4. So that's going to be negative 16 plus negative 8, which will give you negative 24. And then finally the last one, negative 1 times 7 plus 7 times negative 9, which will give you negative 7 plus negative 63, which will give you negative 70. Okay? Alright. The next thing we're going to look at is if they are orthogonal. Orthogonal is basically perpendicular, and the way that you know that is if the dot product is equal to 0. So we're going to calculate the dot product here. These are just in component form. Basically, we call them IJ form. So this is your kind of your X-ish type of, and this is your Y. If I were to write these in standard form, it would be 2, 3, and this would be vector 6, 9. Okay, so I would do 6 times 2 plus 9 times 3, and there's really no way of getting 0 here. So my dot product is 39, and these are not orthogonal. I'm going to abbreviate. So over here I would do half times negative 6 plus 3 times negative 3. That would give me negative 3 plus negative 9, and so therefore these are not orthogonal either. Down here I'd have half of negative 4 plus negative 2 times negative 1. Oops. Which would give me negative 2 plus 2, which would be 0. So these would be orthogonal. And finally, negative 9 times 2 plus negative 9 times 2, which would give me negative 18 plus negative 18. So therefore negative 36, and these are not orthogonal. Okay, so the only one that is orthogonal in this case is number 9, because my dot product is 0. Alright, in these we are looking at equations. So if the dot product of the vectors, these two vectors, negative 3, negative 2, and 4w, is negative 32, I'm looking for the value of w. So remember, dot product is taking the two x values, the 2 in this case u. I take negative 3 times 4, and add to that negative 2 times w and get negative 32. From here I would just solve this equation for w in order to find what that value is. So my two-step equation would be negative 12 minus 2w equals negative 32. So I'm just then going to add 12 and divide by -2. So W is going to equal 10 in this case. Okay. Next one I'm going to do the same thing. So x times -1 plus 5 times 2 equals 7. So therefore my equation is -x plus 10 equals 7. So if I solve that equation for x, I'm going to subtract 10. -x equals -3. Divide both sides by -1 and x equals 3. And then finally again on my last one, I'm going to take -2. Again, -2 times 8 and then x times 1. Both of those are going to equal 16. That's that word is. So -2 times 8 plus 1 times x equals 16. So that would be x minus 16 equals 16. I'm going to add 16 to both sides, and x equals 32. So that's just finding an x value if you know the dot product. Okay. Magnitude. So in this case, -8, 2, that would be in your third quadrant. So you have to be careful here because when you calculate this problem, okay, there's a couple of different ways that you can do this. First of all, this is a value of 2 and this is 8. There is, first of all, magnitude that we're going to find. So for this one, my magnitude is going to be the square root of -8 squared plus 2 squared. Now you have to be careful. If you put this in your calculator, you do have to be sure you put that -8 in parentheses or it will give you a different answer. Okay, so we're really looking at the square root of 64 plus 4. So therefore we can just leave our answer as root 68. You really don't need to find the decimal approximation for that. Okay, so that's magnitude. That's just basically how long this value is. This is the magnitude of A. Okay? Alright. The next thing we're going to look at is the direction. And again, -8, 2 is that same point that we had here. We are going to have to use trig to find this. And then, after we use trig, we're going to have to determine what the actual angle is. Because remember, our angle is determined by... Oops, my flip chart's frozen here. Just give it a second. So it's determined by using the tan inverse. But remember when I do this, this is -8 and this is 2, but notice I'm looking at, this is not magnitude, this is absolute value. I always just like to label my triangle and then go from there. My flip chart is locking up right now, so I apologize. Alright, so I'm experiencing a little bit of technical difficulty, so I apologize. But the angle that I'm finding is actually this angle right in here. And the angle that I actually want is the angle that it goes from here and rotates around just like the unit circle. Okay, so this is ultimately the angle I'm going to need to give for my answer because I want the direction angle. But to do it, I am going to have to do tan inverse first. Okay, so we're going to open up our calculator here, if my computer will let me, because it's being... Let me pull up. Alright, so I'm going to take the tan inverse of the y value, in this case, which is 2, over the x value, which is 8. And notice I'm doing the absolute value. I'm not worrying about the negatives or anything. I'm just looking at it as a triangle right now. So if you go to your calculator, you do need to make sure that your calculator is in degree mode. So if you hit your mode button and make sure you're in degree, I can then just do the tan inverse of 2 over 8. Now remember what that gives me. That gives me that angle, which is 14.036. okay, which it gives me this angle right here, but that's not the angle I need. Remember, the angle I need is starting here and going all the way around. So in quadrant 3, whatever I get for my angle in quadrant 3, I take 180 degrees and I subtract that 14.036. So remember, whatever you get for the angle here is just the angle. This is quadrant 1. In quadrant 2, oh my goodness, I said quadrant 3. I apologize. That should be quadrant 2. Okay. In quadrant 2, I take 180 minus the angle. In quadrant 3, I take whatever I get for the angle and add 180. And then over here, I take in quadrant 4, I take 360 and I subtract the angle. Okay, because remember, all the way around is 360. So in this case, I'm going to say that my direction angle is 180 minus, and I'm just going to take the answer that I had, 165.964. And that's degrees. Please don't forget that. So this is ultimately the angle that I'm looking for. I'm looking for the direction angle. And again, I use the concept of trigonometry, which is the tan inverse, but that will only give me that theta value, and then I have to determine which quadrant I'm in. Alright, we are going to now move into forces of objects. So two forces with magnitude of 10 pounds and 13 pounds are applied to the object. So if my object is right here, I have a force of 10 pounds and 13 pounds being applied. So here's going to be my 10-pound force, experiencing some technical difficulties again, and here is going to be my 13-pound force. Okay? The resultant force is 15 pounds, so I know that my result is going to be 15. So that segment that comes between those two vectors is going to be my result. So to solve these, the best thing to do is to go ahead and complete a parallelogram. So you're going to literally draw a side that matches that vector, and then another side that matches the other vector on the other side, and then your resultant force is what's given to you as the 15. So this is 15. Okay? I'm going to zoom in on this just a little bit so I can clean my picture up. Okay. So it says that I want to find the magnitude, so or the angle of this right here. So it's this angle right here. So it's the angle between the 13-pound force and the resultant. Okay? So what I would do, again, I want that angle right there, is I would call, I would go ahead and label my sides, because remember, those are equal. It's a parallelogram. And then I'm going to have to use law of cosines in order to determine that. Okay? Because I have all three sides, remember, if I have side, 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 to find the angle, I have to use law of cosines. So I always start with the side opposite of the angle I'm trying to find. So I'm going to say 10 squared equals 15 squared plus 13 squared minus 2 times 15 times 13 times the cosine of that angle I'm looking for. Okay? Then I'm just going to simplify. So 100 equals 225 plus 13 squared, which is 169, minus 2 times 13 times 15. So I'm going to do 2 times 13 times 15. Oops. 2 times 13 times 15. And that's 390, and then cosine of theta. Now what a lot of students like to do is they like to put all these in, but you cannot do this. This 390 has to stay with this cosine. So what I'm going to do is I'm going to just take the 225 plus 169 and get a number. That's 394. I'm going to say 100 equals 394 minus 390 cosine of theta. Now I'm going to subtract 394 from both sides. That's negative 294. Oops. Oops, sorry about that. Which is going to give me negative 390 cosine of theta. Then I'm going to divide both sides by negative 390 and then take the cosine inverse. So I'm going to keep that as 294 over 390 when I take the cosine inverse. Okay, so again in your calculator you're in degree mode. Cosine inverse of 294 over 390. And you get 41.075. And remember that was an angle that I was looking for because it's theta. And I'm done. So the next one you're going to do the same way. I'm going to pause the video right now and complete the problem, and then you'll be able to see it and you can pause and look at my work. Alright, so number 6, again you want to have this diagram. You're looking for this angle theta. So you start with the side opposite and plug it into law of cosines and then solve. You should get 50.533 degrees. Alright, again more of the same, however with this one, you know the two magnitudes and the angle between, and you want the magnitude of the result. So your diagram here is going to look pretty similar. Okay, however, you do need the supplement of that 55 because in a parallelogram, I can't remember the name of those two angles. This angle and this angle are going to be supplementary. So I'm going to take 180 minus 55 to get this angle right here. Okay, so when I do that, I'm going to be left with 125. And I want to know x. Okay, so with this problem, I know that this angle, and I'm trying to find the angle opposite. I know this side, and I also know this side. So for this one, I have a side angle side situation. So I know, again, I'm going to use law of cosines, but this time I need to find x. Okay, so I'm going to say x squared equals 14 squared plus 20 squared minus 2 times 14 times 20 times the cosine of my angle, which is 125. And then I'm just going to plug all of that in my calculator exactly as it looks. So I'm going to say 14 squared plus 20 squared minus 2 times 14 times 20 times the cosine of 125. Again, you need to make sure you're in degree mode, but again, I just put all that in, and then notice that's 917.203. And now that's x squared, so I have to take the square root of both sides. So I'm going to take the square root of my answer. Oops. And I'm going to get 30.285. And that's in pounds, because that's my magnitude of each. Okay, so again, I'm going to go ahead and pause the video, complete the problem, and then you'll be able to look at it. Alright, so here is your answer for number 14. Again, supplement of the angle, so this would be 100 since this is 80. Then plug it right into law of cosines, take the square root, and you get 84.088 degrees. Oh, excuse me, that's not degrees. That should be in pounds because I'm looking for the magnitude. Okay, let me make sure that looks like pounds. Okay. Alright, I'm going to go ahead and pause this video. I'm going to start a new video for parametric equations.